I'm Mueen Beaver, and I am presenting our article on the care and feeding of virtual assistants, automating conversation review with AI. First, to present the problem we're being faced with. We at Verint create virtual assistants for customer service. They're out talking to their users over various channels such as voice or text or social, and they're generating these conversation logs. Now, to make sure our virtual assistants are doing the job appropriately, we need to grade these logs and look for any issues which might be surfacing. We have limited resources to do this work, so therefore we take some form of a sample for review. It might be a random sample, it might be some metric such as confidence scores or if events occurred within a conversation we're interested in. But these reviewers take this subset of these conversation logs and they look for things where the virtual assistant communication could be improved, or maybe its knowledge. They then create these recommendations as to what needs to be improved, and they pass this on to the domain experts. These are typically machine learning engineers or natural language processing experts that maintain the models that are running in the live virtual assistants. They make the necessary corrections, train new models, and these improved models get deployed to the virtual assistant, therefore completing the refinement cycle. Now, there's several existing issues with IVA evaluation. For one is the error correction latency. As long as it takes for this refinement cycle to complete, these errors or knowledge gaps are still out there being experienced by the users of these IVAs. Also, we have difficulty scaling to high volume IVAs as we have limited resources to the actual review. It's also inefficient to use humans to review conversations where there are no errors because there's really nothing to be done downstream. Therefore, as IVAs are improving through this refinement cycle, we're surfacing more and more conversations where maybe there's really not anything that needs to be done. The cost of human labor is only increasing over time. Regardless of how good the sampling method is, it's still incomplete coverage because there will always be errors that aren't surfaced by that particular method. Every method has its individual biases, and also there might be more errors than there are, say, sampling volume. These human reviewers are subjective in what they're doing, so they're making determinations about communication, say saying a virtual assistant is misunderstanding this user input, where another user will read that same conversation and come to a different conclusion. Therefore, the recommendations they're making are also subjective and may have conflicts. There's also been public outcry lately over privacy concerns related to human reviewers reading and listening to conversations that may contain, say, sensitive account information or public health information. So in order to overcome these problems, we created AAAI, which is the product name for an automated IVA evaluation solution. Our approach to this was first consulting literature on communication theory and psycholinguistics and so on for observable features of communication between two conversants. We then interviewed seasoned human reviewers that have been doing this for years for what are the features that they're looking for in these conversations that indicate IVA failures or knowledge gaps. For each of these features, which we ended up with around 35, we devised a way to identify it automatically, whether that was a heuristic or a model that we trained or some algorithm. Some example of some conversation level features, which means we have to look at the context of the full conversation to make a determination, would be if a user is restating themselves over the course of a conversation, if they're using correctional language downstream, or if you see a similar user intent matched more than once within a single conversation. Some turn-response pair type features include looking to see if the user's input contains relational language. For example, a bunch of backstory on why they're trying to perform some task, if they're using words that are unknown to the IVA, or if the IVA's responses are too complex, using a bunch of complexity measures. So we then take the outputs of all these feature detectors and combine them into a score for the risk of misunderstanding occurring within this conversation. We rank these for review, and then we generate a correction recommendation based on the error types that we have detected within this conversation or within this turn response pair. Here we see where we've injected AAAI into this refinement cycle. Instead of taking some sample and giving it to human reviewers, AAAI looks at the full set of conversation logs. It then does its risk analysis and ranking and provides its recommendations, and it sends those off to the domain experts directly. Now, these feature detectors and algorithms and things require periodic training, which we can bring in reviewers to do, which is now just a small portion of the human work that was necessary as before. AAAI has now been in production for several years, and we have the following observations. We've done some customer case studies where we compare the existing manual refinement process with Trace AI and found the same conversations are getting surfaced, plus some additional problematic conversations that the sampling method was missing. After deploying Trace AI, we've observed roughly a 75% reduction in our monthly human annotation costs. Now, humans are only reviewing as necessary to train and tune these feature detectors within Trace AI, and they're not reviewing nearly as much data as they were, which has increased user privacy. We can now generate an IVA communication score by looking at the proportion of these high-risk turns over some time period, which was something we were unable to do before.